Hi everyone, my name is Jody. I'm the Technical Sales and Service Manager here at DeFelsko. We're here today to talk about the PosiTector DPM dew point meter for monitoring environmental conditions. Before we get into the functions and operation of the gauge, just a few housekeeping items. This is our third in series of webinars, so if you have not checked out our previous ones on our PosiTector SST or PosiTest LPD, please see our website. They are both recorded there and you can watch them at your leisure. This webinar will be added to that list in a couple days. We just need a few days to edit it. Also, you'll notice in the Go to Meeting box there is a chat box. If you have any questions or comments throughout the course of this webinar, please feel free to type them in that box. At the end of this presentation, I will answer as many of them as possible. If you do have a question that requires a little bit more of a technical answer, we will reach out to you after this to make sure you get the information you need. With all that being said, let's get into our PosiTector DPM dew point meter. So why do we measure environmental parameters? The primary reason is environmental conditions during the application of a coating can greatly affect the coating's performance. And we're going to talk about a few of those parameters here today. First off, let's talk about humidity and dew point. And I know most of you are aware of this, but just as a little bit of background, dew point refers to the temperature at which moisture in the air will fall out of the air and condense on the surface in the form of a liquid. If this were to happen as you were applying a coating and that liquid became trapped underneath the coating, it could lead to future corrosion and failure of your coating system prematurely. Additionally, if you have an environment where the humidity is very high, it will affect the evaporation of your solvents from the coating, which can affect the cure of the coating and lead to premature failure. The next parameter I want to discuss is surface temperature. If you have a surface temperature that is either too hot or too cold at the time of application, it can affect the way the coating adheres to the surface and again can affect the cure of the coating. This can shorten the life of the coating and ultimately lead to problems down the road. Next, we're going to talk a little bit about wind speed, and this is a parameter that is coming up more and more in recent times. We're starting to see some specifications related to wind speed. The primary factor related to wind speed, and probably the most important one, is safety. If you have workers that are working on ladders or scaffolding up high on a bridge or at a high tank painting, and you have a wind speed that is too high, it can affect their safety. That's priority number one. Additionally, as we mentioned with humidity, wind speed over the surface of a coating as it's drying can cause the solvents in the coating to evaporate too quickly. Most coatings have a certain evaporation rate that they're expecting to get the proper cure, so if you accelerate that evaporation, it can lead to an improper cure for the coating. And last but not least, if you're painting a structure in a wind speed that is too high, you may end up painting something downwind that you didn't mean to. This can lead to higher cleanup costs and can ultimately lead to you using more paint than you had originally intended. So, let's talk about the advantage of a digital environmental gauge such as the PosiTector DPM over the traditional way of doing this. The main advantage of this type of instrument is that it replaces 4 other devices. It's going to replace a surface temperature thermometer. The PosiTector DPM has a surface temperature sensor on the bottom. And it's going to replace a sling psychrometer, psychrometric tables, and a barometer, which are used to calculate relative humidity, wet bulb temperature, dry bulb temperature. Now you can see from this chart behind me here, we've illustrated an example here. When you're using a sling psychrometer, there's a bit of subjectivity there. The way that I swing the psychrometer over my head might be slightly different than the way you do it. Additionally, as soon as I stop swinging that psychrometer, the temperature is going to start changing a little bit. And you can see from this example here, even the slightest change, a ½ degree change in my dry bulb temperature affects my relative humidity by over 8 points. So when you're using a digital gauge, such as the PosiTector DPM, there is no subjectivity. The number you get is clearly displayed on the screen. You don't have to make a judgment call. And when you want to take the reading, you push the plus button on the gauge. It stores the data set into memory. There is no guesswork. You can then use that on a report down the road. So let's talk a little bit about principles of operation, and I'm going to ask Hannah here to fade me out of the picture so we can look at this slide all together. The PosiTector DPM measures and records the following climactic parameters: air temperature, surface temperature, relative humidity, dew point temperature, which is a calculated value, surface temperature minus dew point temperature, and this comes into play with some job sites where they actually have a specification that the surface temperature cannot be too close to the dew point temperature, and this is for the reason we mentioned previously, that if you actually were to hit your dew point during the course of your coating application, you may have some condensation form. Advanced gauge bodies will also display wet bulb temperature, and the PosiTector DPM model will display airspeed or wind speed. Now, you can see on the screen here an example of a memory mode display. What this is showing you is pretty much how the parameters are displayed on the screen of a PosiTector DPM. It's also showing you that this particular gauge is displaying two alarm conditions. That's the relative humidity and the TS minus TD, or surface temperature minus dew point. You can tell they're in alarm position because they are red and there is a little bell next to them. Now, an alarm can be pre-established for any of these parameters in the gauge. You can set the point at which you want the gauge to alarm, and it will show visually by displaying it in red. It will show audibly by sounding an audible alarm, and you can also set a PosiTector advanced gauge body that's connected to Wi-Fi to send you an email alert if your parameters exceed the predefined parameters. So this is a very powerful tool, especially if you have the gauge in an auto log mode, which is what we're going to talk about next. One of the key features of the PosiTector DPM is the ability to do auto logging. Now, what you can see on the screen here is a PosiTector DPMS attached to an I-beam with its magnetic surface temperature probe attached to a surface. This is a configuration that we normally use to show the auto logging mode because the back of that particular PosiTector DPMS has a magnet in the rubber boot, and this gauge has been left presumably at a job site or in a factory condition or in a factory situation where there is nobody there to monitor it. This gauge can be set in the auto log feature, as you can see on the screen here, at a predetermined interval. This particular one has been set to 5 minutes. So what will happen? This gauge will take a reading every 5 minutes and store it into memory. An advanced gauge body will power down in between readings to preserve battery life. Additionally, if the advanced gauge body is connected to Wi-Fi, each reading is uploaded to posisoft.net, and our PosiSoft desktop software now has the ability to remotely monitor these settings or these readings as they are taken. So that's a new feature. The auto log feature is one of the best features of the PosiTector DPM, and it's a very powerful monitoring tool when you actually don't want to have an employee sit and monitor your environmental conditions. Okay, one of the prominent questions we get with the PosiTector DPM is related to acclimation, and I'm going to fade back in here. So we wanted to address this during this webinar because if you're selling this gauge, this is a question you will probably get. What we mean by acclimation is the sensors within the PosiTector DPM need a little bit of time to adjust if you move from one environment to another. Specifically, if you move from one environment that has a very low humidity or low temperature to one that has a high humidity or high temperature. If you think about the relative humidity sensor as a sponge, it takes a little bit of time when you go between environments for that sponge to either absorb or evaporate off the moisture it's containing, that in order to get a good reading. So if you're in your car and you're driving to a work site, you have your air conditioning going, the relative humidity in your car is low, the temperature is low, and you step out into a job site where your relative humidity is high, your temperature is high, you need to give the sensors in the gauge a little bit of time to adjust. Now, the surface temperature sensor will adjust very quickly. As you can see, if I put my finger, if I turn it off, if you put your finger on this, it will adjust very quickly. The air temperature sensor will adjust fairly quickly. It may take a minute or two to get up to temperature or down to temperature if you move between. But the humidity sensor takes a little bit longer. We generally recommend if you switch between extreme environments, 30–40% humidity change, that you give the gauge 15 to 20 minutes to stabilize. And we get this question a lot. We have people call that have just stepped out of their car onto a humid job site. They're looking at the gauge, they're looking at their weather app on their phone, and they call and say they don't match. 99% of the time, it's simply because they have not given the gauge enough time to acclimate to the new environment, and once they do, the readings come right in line. Another point with acclimation is if you have a PosiTector DPM probe that you haven't used for a while. For example, if you were working during the summer months using it all the time, Winter comes, you don't do a lot of outside work, you take the probe, you store it in your desk. Before you take it back out and start using it again, you're going to want to recondition that humidity sensor to be ready to take accurate readings. The way we recommend doing this is to wrap the probe in a damp paper towel overnight, and you should be good to go after that. That kind of reconditions that sensor, gets it ready to give you accurate readings again. We just wanted to touch on this briefly because if, like I said, if you are selling this probe and this gauge, it is a question that you will face from time to time. Okay, so let's talk a little bit about competitive advantages of the PosiTector DPM. The primary advantage is going to be the PosiTector platform. This can't be overstated. The ability to switch interchangeable probes on a single gauge body is a huge advantage of the PosiTector platform. I can take the DPM probe off. All I have here is other PosiTector DPM probes, so I'll just put a different one on and you can see the gauge will automatically recognize the new probe. It starts reading immediately. This will also happen with other probes in the PosiTector line, whether it be a PosiTector 6000 coating thickness, a PosiTector UTG wall thickness, PosiTector SST salt tester. You get the idea. The probes work interchangeably on the gauge bodies. This is a very powerful selling point. Customer buys one gauge body, several probes. They essentially have multiple instruments in one case. Next, we have the certificate of calibration. DeFelsko includes a certificate of calibration at no additional charge with all of our probes. This is a long-form certificate, so it actually records the data that we acquire when we calibrate the probe. And this is not something that's very common. A lot of manufacturers either charge for a certificate or the certificate you get does not have all that information. So this is a very good selling point for your customers that are really concerned about traceability and calibration. Next, we have the full 2-year warranty on body and parts. This is standard with all DeFelsko products. This is not standard across the industry. And to get the full 2-year warranty for DeFelsko products, you don't need to do anything special. You don't need to register the gauge. They come with this warranty right out of the box. And it's a very uncommon thing in the industry to have a warranty this long. A lot of them are 1 year or even less in some cases. And finally, we have DeFelsko's service, quick shipping, recalibration, and repair. For those of you that don't know, we do all our manufacturing, repair, recalibration, and service right here in-house. These gauges are manufactured not too far from where I'm standing. They are recalibrated in the same building. They are repaired. So everything we do is done right here. So we can turn these around very quickly for you. One note on recalibration of a PosiTector DPM, because we do have to put the instrument through its entire range of relative humidity and temperature, it does take a little longer than our other gauges. Whereas a PosiTector 6000 we will turn around in 1 day for recalibration, a PosiTector DPM can take 5 to 7 days to get recertified, and that's just because of the nature of the probe. So just something to be aware of and something to make your customers aware of if you are sending probes in for recalibration. So let's talk about the different types of PosiTector DPM probes. The first one we're going to talk about is the PosiTector DPM. This is the built-in contact style surface temperature probe with a relative humidity sensor, air temperature sensor. It will display dew point, surface temperature minus dew point, wet bulb if you have a advanced gauge body. This is probably the probe that most of you are familiar with. It comes with all of our pre-configured inspection kits. And if you're familiar with a PosiTector DPM at all, this is probably what you're associating with it. Next, we have our PosiTector DPMS, and I'm going to use this little plate here because this really kind of illustrates it. This plate is made of metal. The PosiTector DPMS we recommend for the auto logging feature. So this particular one has the magnet on the back of the rubber boot. You can see it sticks. I have the magnetic surface temperature probe. That sticks also. This is very handy for doing auto logging. This is actually the newer style PosiTector DPMS that we released not too long ago. So the cable is a little more reinforced, the strain relief is a little more reinforced, and this is a different magnetic surface temperature sensor. This one's silver, the other one was black. So we have made some improvements based on feedback we got from the dealers. The next one we're going to talk about is the PosiTector DPMA. And this, let me move over here. This is one of our newer PosiTector DPM probes. This is used for measuring wind speed. And just to show you, if it's not set up to measure wind speed, It measures just like a regular PosiTector DPM. It has all the same sensors: surface temperature, air temperature, relative humidity, and it'll work just like a PosiTector DPM. When I put it into anemometer mode and I slide the little collar down, I now expose the hot wire anemometer, and now I have a wind velocity reading. Now, just a note on the hot wire anemometer, there's a close-up of it right here, and you can see in the opening there's a little wire with a little ball on it. That is the hot wire anemometer. The reason we went with a hot wire anemometer is pretty simple. There is no moving parts on this particular sensor. When the wind flows across that hot wire, it lowers its temperature. The gauge compensates by adding a little bit of energy. By the amount of energy it adds, we can calculate a wind speed. So there are no moving parts to this. This is opposed to a vane-style anemometer, which has a propeller. In order for the propeller to get a proper reading, you have to overcome the force of friction to get that propeller spinning. Because of that, the hot wire anemometer is much better at lower wind velocities than a vane style like this. We do recommend, when you're not using the anemometer, you keep the collar up to protect it. That is a very sensitive wire. If you do get any dirt or anything in there, you can blow on there gently to clean it out, but we do not recommend sticking anything in there because it can damage that sensor. If that does happen, please send it in to us. We can clean that up for you. The last one I'm going to talk about on this slide is the PosiTector DPM-D, and this kind of has a very specific application. We had a lot of our customers, and this one is over here, we had a lot of our customers working in the pipeline that were using the PosiTector DPM to measure relative humidity, temperature, and a calculated dew point in a pipeline application. What they were doing was opening up a hole in the pipeline and trying to hold the gauge over top of that hole. Not the best solution, doesn't give them a closed solution. So we came up with this. It's got 1/2-inch NPT threads and a sintered metal end to protect the sensors. So I have a piece of pipe here. Essentially, you take this and you can screw it right into an open bung on a pipeline. It gives you a closed system. It records air temperature and relative humidity inside the pipe, and it will calculate your dew point. This does not record surface temperature. Obviously, the sintered metal end is in place of where the surface temperature sensor was, but our general experience with talking to our pipeline customers was that they did not require that particular sensor. They were more interested in air and dew point. So those are the 4 probes we'd have up till now, but I know what most of you are interested in is the new PosiTector DPM IR. This is very similar to the PosiTector DPM, except instead of the contact surface temperature probe, this has an infrared thermometer to measure surface temperature. There are some obviously significant advantages to this. I do not need to make contact with my surface to take a reading. If you're working on very hot or very cold surfaces, or a surface that you cannot actually make contact with, this could give you a very good solution. It has a much wider range of temperatures it can measure, from -70 to 380 degrees Celsius, which is quite a bit wider than our contact temperature sensor on the PosiTector DPM. It has an emissivity that is adjustable, and for those of you that are not sure what emissivity is, it simply refers to the ratio of how much infrared radiation a surface is emitting, and it gives the gauge a way to tell the difference between different surfaces. They all have a slightly different way they emit infrared radiation, and that adjustable emissivity lets us account for all that. It has a 4-to-1 distance to spot ratio, and we'll pull up a little graphic here to show you what this means. So the distance to spot ratio refers to how far above the surface the gauge is versus how much of an area it's measuring. So when I'm 4 inches off the surface, I'm measuring a 1-inch spot. 8 inches up, I'm measuring a 2-inch spot. 12 inches, a 3-inch spot. You get the idea. Now, one thing to keep in mind, when you are measuring with the PosiTector DPM IR, it is taking an average over that whole spot that it's measuring. So if you're measuring on something that's half hot and half cold, you're going to get the average of the 2 temperatures. Just something to keep in mind. This probe is now available. It was released last week, so this is available for purchase. It can be purchased with either a standard or an advanced gauge body, or as a probe by itself. And if you would like more information, I encourage you to check out the website seen here. You can also shoot us an email or give us a call, and any of our sales staff would be happy to go over it for you. So that concludes our primary presentation. We're going to pause for a moment here to take a look at any questions or comments that may have come in. Please feel free to keep typing. I'm going to take a break for about 30 to 45 seconds here, and I'll be right back with you. Okay, we're back. We didn't get a whole lot of questions, but we did get one that I do want to address, and that question was, when would you sell or when would you recommend the PosiTector DPM IR over the traditional PosiTector DPM? The answer is, for most applications, you would want to use the PosiTector DPM with the surface contact temperature probe. It's the industry standard. It's easy to use. If you can make surface contact and it's within the range of the sensor, then that's the one I would recommend. The PosiTector DPM IR is great when you have very hot or very cold surfaces, or a surface that you can't quite make contact with. But one of the disadvantages, I shouldn't say a disadvantage, one of the advantages of the regular PosiTector DPM is that you don't have to worry about emissivity or distance to spot ratio. It is something to keep in mind with the PosiTector DPM IR that you do have to know what the emissivity is in order to get a good reading on a surface. It does have a default of 0.95, which will work for most surfaces, but for some specific surfaces, you do have to know the emissivity, and that can be a little challenging. I see we do have another question that just came in that said, what is the maximum measuring distance with the new IR? Well, really the answer is it will measure quite a ways out, but what you have to keep in mind is it's averaging everything that's coming in on that cone. So if I'm measuring 10 feet away, I'm measuring a spot that is 2.5 feet in diameter. If I'm measuring further than that, you can tell that spot keeps blowing up. So the further you go out, the more area you're measuring. And that's really something that a specific customer would just have to know ahead of time before they tried to take a reading that was 30 or 40 yards away. It's just not going to give them the greatest temperature reading because it's averaging a very large spot. The closer you can get, the better it's going to be. But just keep in mind, it will read quite a ways. It's just going to average that whole area. I hope that answered your questions. Please, if you have follow-up questions that you didn't think of during the course of this webinar, my contact information and DeFelsko's phone number is on the following page. I'd be happy to chat with any of you on the phone or via email, as would any of our sales staff. As I mentioned, this webinar will be recorded and saved to our website shortly, and we hope to see you again at a future webinar. For now, I'm signing off. I hope you enjoyed it, and we'll talk again soon.